Alright, so here's a video to summarize the results of the red, blue, green, and white light experiment with the leaves, alright? I took some bramble leaves and I put them underneath a light for about 30 minutes or so just to get them photosynthesizing because it was snowing outside, so they weren't really, I don't know if they were photosynthesizing or not before. Okay, so the one that I put underneath a green filter, this has been running for over 3,000 seconds here. It's really not changed that much. You go from 410 to about 440 and it's rising. If it were doing photosynthesis, it would be decreasing. Also, it's just a lot of data errors, and so you see it's more data collection trends than you see actual CO2 happening, okay? So in this setup, it's been inside of this box, and the carbon dioxide is measuring just a single leaf in there. Okay, if we go over to the blue light, at first, what was the leaf underneath the blue light started to decrease, but then it started to rise. And the reason is because this blue filter filters out a lot of light. So the green filter has about 70 lux, or a light intensity of about 70 lux. This one has a light intensity of about 79 lux, but this only has like 45 lux. So it's actually getting a lot of the light intensity out, and so that light intensity was really not enough for it to do photosynthesis. So because of that, there was more cellular respiration happening, and you saw a rise in CO2. So what I did was I removed the blue filter just to have pure white light, and after that, it really started decreasing. In fact, the slope of decrease for the white light was way more than the slope of decrease of sequestering for the red light, because the lux for white light is 405 lux, whereas the red light is just 79, okay? So yes, we are filtering the light, but we're also getting less light intensity. So the blue light really is not good for measuring if photosynthesis is happening or not, because it is not comparable to the red or to the green. I have printed off a lighter blue on a transparency, so I'm going to see if that affects the luminosity in a moment here. The red right here was great. So the red was really good at photosynthesis. You could see a clear decline. And we're at 113 parts per million right now, and we were at about 400 before. So we are seeing a pretty good decrease in sequestration after about 4,000 seconds, all right? So the lux is pretty comparable when it comes to the green and to the red, but the blue is kind of out of the picture here. This was, did take a while to set up, so this would be fun for students to, like if they design their own experiment with the control group, and then with their experimental groups, that would be really cool. Red, I mean, they might conclude that a red filter would not help photosynthesis, but that a red light bulb maybe. So if you could get maybe a red, one of those light bulbs that changes red color, that might be great. Just to, instead of comparing filters, what happens if you compare the light bulbs? I'm not sure what that would look like. Okay, so I'm sure that there's different light bulbs that you could use. Either way, this would be good for a demonstration. So if I just had this set up and the students walked in, and at the beginning of the class I started the measurements, and then in the middle of class I had them walk over and look at what was happening, this would be a good demonstration just to show them how photosynthesis works, even if it's not a lab that each student does individually. All right, now this is very weird. The red is going down as expected, and I'm using transparencies now. Okay, so this is printed on a transparency. You really can't even see in there, okay? This is the blue. The blue should be going down because it should be photosynthesizing. Instead, it's going up. So that doesn't make any sense. The green should not be photosynthesizing. However, it is still taking in carbon dioxide. I don't think it's very green. So I am going to put an extra set of filters on in this next round and see what happens. All right, red filter, normal filter, you have a decrease with the red. With the green, you really have hardly anything. It's like 5 parts per million, whereas this one with the red was 80 parts per million. Here you have about a 80 part per million increase with the blue light, which was unexpected. All right, after testing these all day, my conclusion is that red light is by far the best for photosynthesis. Green light is actually better than blue light because of errors in graphs and biology textbooks try to make you think something different based off of an experiment from the 1960s, but it does not take into account the full holistic approach of looking at plant leaves, and so red is going to be better. You could do an experiment on how red is better than green. But in general, the conclusion is that the best light is just white light. Also, another thing to note is that the light intensity of the green light is greater than the light intensity of the blue light. So you don't have a constant in the light intensity. So because of that, it's not a perfect experiment.